We look to the heavens with awe and ambition. We send robots to Mars, probes to Jupiter, and dream of walking on other worlds. But beneath the waves of our own planet lies a realm more alien and unexplored than the surface of the Moon or Mars. So, why does humanity seem to favor the infinite void above over the mysterious depths below? Today, we're not just asking a philosophical question, we're exploring the scientific, technological, and economic realities behind this apparent paradox. The short answer is, it's not about desire, but about degree of difficulty. Exploring space and exploring the deep ocean present two fundamentally different sets of challenges. Let's break them down. 1. The tyranny of pressure. This is the single greatest factor, pressure. In space, the primary challenge is containing a mere 1 atmosphere of pressure inside a spacecraft or suit to keep astronauts alive in a vacuum. The outside pressure is 0. But in the deep ocean, the pressure is immense and comes from the outside. For every 10 meters you descend, the pressure increases by 1 atmosphere. At the average depth of the ocean, about 3,800 meters, the pressure is nearly 400 times greater than at the surface. That's equivalent to having one person balanced on your every square inch. Building a vehicle that can withstand this is phenomenally difficult and expensive. The windows must be incredibly thick acrylic or complex cones. Every seal, every electrical penetration, is a potential point of catastrophic failure. A tiny leak in space causes air to rush out. A tiny leak in the deep sea causes water, under immense force, to rush in, instantly crushing and flooding the vessel. As Dr. Gene Feldman, an oceanographer at NASA, once put it, it's easier to send a person to space than to the bottom of the ocean. We can send a spacecraft to Pluto and get data back, but we can't send a person to the deepest part of the ocean without taking enormous risks. 2. The problem of perception. The second major challenge is communication and navigation. In space, we can see. We use radio waves, which travel effortlessly through the vacuum at the speed of light. We can talk to the Voyager spacecraft, now in interstellar space, with a delay of over 20 hours, but the signal is clear. In the ocean, light disappears. Below 200 meters, it's perpetually dark. Radio waves are useless. They're absorbed by water within meters. The only option is sound, sonar. But sound travels slowly, can be distorted by water temperature and salinity, and is a low-bandwidth technology. Sending a simple message is slow. Transmitting high-definition video in real time from the deep sea is a monumental task. You are essentially blind and deaf compared to the connectivity we enjoy in space exploration. 3. The economic equation. Now, let's talk about a less scientific but equally powerful driver, economics and tangible benefits. Space exploration, while expensive, offers immediate and colossal economic returns. The global space economy was valued at over $400 billion in 2020. GPS guides our cars and phones. Satellite imagery predicts weather, monitors crops, and manages disasters. Telecommunications run through satellites. There is a clear, profitable business case. The deep sea, for now, lacks that immediate large-scale economic incentive. While we extract oil and gas from continental shelves and lay cables on the seabed, these activities are in relatively well-mapped areas. The true abyssal plains and hydrothermal vents don't yet offer resources that are cheaper to extract than their terrestrial counterparts. Mining manganese nodules or rare earth elements is technically possible, but the environmental costs and immense engineering challenges make it currently unprofitable. 4. The psychological pull. Finally, we cannot ignore the human spirit and imagination. Space is the realm of inspiration. It represents our future, colonizing Mars, finding alien life, understanding the cosmos. It's a grand, uplifting narrative that has captured humanity's imagination for millennia. The deep ocean, in our collective psyche, is often associated with fear, the unknown, the dark, the crushing pressure. It feels more like a niche scientific pursuit than a grand human destiny. This inspiration gap influences public support and, consequently, government funding. NASA's budget is over $20 billion. The budget for NOAA's Office of Ocean Exploration and Research is around $30 million. The difference is staggering. 5. A false dichotomy? The symbiotic future. So, is it really a choice? Are we ignoring the ocean? The most important point is that this isn't an either/or proposition. In fact, space and ocean exploration are deeply linked. We use satellites to study the ocean from above, tracking currents, measuring sea level rise, and even using gravity mapping technology to infer the topography of the seafloor. Conversely, technology developed for deep-sea exploration, like robotic arms and extreme environment sensors, is directly applicable to designing robots for space missions, such as those planned for Europa, an ice-covered moon of Jupiter with a suspected subsurface ocean. Dr. Kathryn Sullivan, a former NASA astronaut and the first American woman to walk in space, who also became a certified aquanaut and dove to the Challenger Deep, embodies this connection. She has stated that the skills for both environments, contingency planning, teamwork in isolation, reliance on technology, are remarkably similar. Conclusion: the question isn't, why space and not the sea? The reality is that exploring the deep ocean is, in many ways, a greater technological challenge than going to space. It's a realm of extreme pressure, total darkness, and communication blackouts. But the need to explore it is just as urgent. The deep ocean is a critical regulator of our climate. It holds keys to understanding the origins of life on Earth, potentially even life on other worlds. It contains biological and genetic resources we haven't even begun to imagine. Both frontiers are essential to our survival and understanding. The challenge of the depths is not a reason to look away, but a reason to look closer, to innovate, to invest, and to remember that the final frontier isn't just above us. It's also right here, below the waves, waiting to be discovered.